So this is about counting significant figures. There are the rules to count significant figures. In first rule is all non-zero digits are always significant. So if you look here, 1.8, this is non-zero. 325 non-zero, 2434, all these numbers are non-zero. So here we have two sig fig. In this case we have 3, and in this case we have 4. So they are all significant since they are non-zero. Rule number 2 says that the zeros trapped between non-zero digits are always significant. So this 0 is in between non-zero. Same here and same here. It's true for all these three examples. So here we have three significant figures. So this 0 is significant and these non-zero are always significant. This yes, this yes, 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 and including these. So we are writing the total number of significant figures. Okay, so this is altogether 3, altogether 4, altogether 6. Now leading zeros are the zeros in front of all the numbers, and they are never significant. So they are just like the placeholder. So here you cross it out, 1. This is the only number this is the only digit which is significant. Here you cross these out. No matter how many zeros you write in the front, the leading zeros, they are not significant. So here again we have only one significant figure. Here you cross these out, they are not significant. We have only 1 and 2 significant figures here. Okay, so here 2, here 1, 1. So this one yes, these yes. In this case the whole thing, all of these, and here all these numbers. All right. Okay, now let's go to the next rule. This is little different. This is about the trailing zeros. So trailing zeros have two criteria: the trailing zeros with the decimals and the trailing zeros without decimals. If you have trailing zeros are the zeros that are at the end. So these zeros which are at the end to the right of the decimal or after the non-zero digit, they are significant. So yes, yes, these are all significant because here also we have a decimal, and non-zero digits are always significant. So we have all together 1, 2, 3, 4. 4 significant figures here, 1, 2, 3, 4, 5, and here 1, 2, 3, 4, 5. 1, 2, 3, 4. 4 significant figures. Okay, guys. So let's how about if this was written like in another form? If you see them written in these forms, we consider only this part. So here only 2 sig figs. Okay, now let me take one more example. 3.90 times 10 raised to power negative 3. So it doesn't matter is the power is negative, positive. We just pay attention to this part, which is 3 significant figures. So it's still following the same rules. This is including the decimal and it is on the right side. And here these both are non-zero. Okay. All right. Here, since there is no decimal, these zeros are not considered significant. So no, no, no. This no, 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 no. These two, yes, because these are non-zero digits. They are always significant. So we have 2 sig figs here, and here we have only 1 sig fig, only this one. And here these both. Since these zeros are not including the decimals, they are not considered significant. Okay, so let's do these examples. These are leading zeros, not significant. So this is the only one significant figure. So one significant figure here. Here, this 0 and this 0, yes, because they are trapped in between the non-zero digits. So trapped zeros, which is your rule number 2, they are always significant. So, and these are non-zero, they are always significant. So 1, 2, 3, 4, 5. We have total 5 significant figures here. All right. So here all 5 of them are significant. Here 1, 2, we have 0 here. This follows rule number 4a. because this 0 is after the decimal and this 0 is after the non-zero digits. So they both are significant. So altogether we have 1, 2, 3, 4 significant figures. Okay, all of them. Now here these are leading zeros which are not significant. This 0 is, yes, it is significant because it is in between the non-zero digits, sandwich in between the non-zero digits. So we have this 3 significant figures. Okay, so how about these here? We don't see any decimal here, so we have only one significant figure since there is no decimal. So these zeros are not significant. Only this is significant. This is a non-zero digit which is always significant. This is actually a defined quantity. This is exact, like an exact number. So this has unlimited significant figures. Okay guys, so for exact numbers, exact counts, there is no limit for significant figures. That's why we say unlimited number of significant figures. And when you have numbers written like these, you just consider this part, and this is following rule number 4a. Both these zeros are significant. So we have total 1, 2, 3, 4 significant figures. So why is it 4? Because these non-zero digits will always be significant. We just pay attention to zeros because that's the tricky one. Here this is again, this is an exact count. So this you have counted, and again this will be unlimited number of significant figures. Okay, now your turn. You try these. You can pause the video and check your answers. If this is what you got, and if you don't get these answers, then just go back and reread the rules. So you need to know the rule numbers, and you need to know the number of significant figures. Thank you guys.